The story of the computer is not one of silicon and circuits, not at its very start. It begins with something far more fundamental, something deeply human. It is the story of a question, a need that has echoed through the ages. How do we count? How do we measure our world? How do we measure our harvests? How do we measure our days? Long before the first whisper of electricity, humanity sought tools to manage numbers. The ancient world gave us the abacus, a simple frame with beads sliding on wires. In its elegant simplicity, it held a profound idea, the offloading of mental labor onto a physical device. It was a tool, yes, but it was also a promise. This desire crossed cultures and ages. Dusty markets of Mesopotamia, scholarly halls of ancient Greece, knotted ropes, the quipu of the Inca, etched markings on bone and stone, Antikythera mechanism, pulled from a shipwreck off a Greek isle, bronze gears and dials, a mechanical astronomical calculator. It could predict eclipses, it tracked the sun, it tracked the moon, it tracked the planets, a machine holding the heavens in its metallic hands, a mechanical oracle. Its existence shows that the dream of a computing machine is ancient. For centuries, that was the state of things. Abacus, astrolabe, slide rule, clever and effective, but limited. They were extensions of hand and mind bound to immediate instructions. A new idea was needed, a machine that could follow a sequence of instructions on its own. The 19th century was an age of steam and iron, a time of thunderous machines and boundless ambition. It was in this world that an English mathematician named Charles Babbage had a vision that was centuries ahead of its time. Babbage was a man obsessed with precision. He saw the errors that crept into hand-calculated mathematical tables. He dreamed of a machine, a clockwork calculator powered by steam, that could produce flawless tables automatically. He called it the difference engine, a colossal contraption of gears, shafts and levers designed to solve polynomial functions with unwavering accuracy. The section he managed to complete was a marvel of mechanical engineering, a testament to his genius. And yet, the full engine was never built in his lifetime. Babbage poured his own fortune and a considerable amount of government funding into the project. The project was plagued by funding disputes, political squabbles, and the sheer difficulty of manufacturing parts with the necessary precision. The difference engine became a grand, unfinished symphony, a tantalizing glimpse of a future that was not yet ready to be born. Even as the difference engine faltered, he conceived of something far more revolutionary, a machine he called the analytical engine. This was not merely a calculator, it was a general-purpose computer. It had a mill for processing, what we would now call a CPU, and a store for holding numbers, what we would call memory. Crucially, it could be programmed using punched cards, a technology borrowed from the Jacquard loom. Working alongside